Practicing circular economy in water management, with Green Float. If the Kaveri misses a single monsoon, Bangalore will run out of water within the next 6 months. And that's the reality. Present challenges. Water supply. Challenge of continuous supply of clean utility water without depleting the groundwater level. In most cases, the tanker water supply also depends on groundwater or nearby water body. Recirculation of sewage can reduce the water load on natural resources. Sewage needs to be treated and discharged. Institutions' apartments are bleeding money to maintain the ever-increasing sewage quantity. Existing treatment also does not ensure the minimization of water footprint because of irregular water quality and lack of zero liquid discharge awareness. Odor and noise. It is observed by the PCB that the majority of STPs, mainly of residential apartments, are either not placed in the proper location, leading to frequent complaints by the residents about noise and odor nuisance. Improper treatment. The plant operators may not be aware of the functioning of various unit operations, and this may result in discharge of untreated sewage, which ultimately joins the water bodies and may also lead to seepage of water from the tanks, thereby contaminating the groundwater. Shock load on STP. During lean time, sewage generation is less than the optimum requirement for the bacterial system to work. Sudden change in inflow quantity or increase in chemical and biological contamination will affect the natural operation of bacteria. The highlight of the new rules for STPs. 1. Treated sewage standards. The pH should be between 6.5 to 8.5. The BOD, on the 5th day, should be less than 10 mg per liter. The COD should be less than 50 mg per liter. The suspended solids should be less than 10 mg per liter. The ammoniacal nitrogen should be less than 5 mg per liter. The total nitrogen should be less than 10 mg per liter. The fecal coliform should be less than 100 mpn per 100 milliliters. 2. Installation of sensors. Online monitoring for pH, TSS, COD, BOD, and flow are required. 3. Fecal coliform control. A dual approach of having a UV stabilizer to disinfect the treated sewage followed by a chlorinator to maintain a residual chlorine level of 2 ppm in the treated sewage shall be adopted to achieve fecal coliform should be less than 100 mpn per 100 milliliters. Ozonation may also be considered with ozone dosage at 4 to 5 ppm. 4. Ultrafiltration system shall mandatorily be provided for the treated sewage reuse for toilet flush and also to avoid recontamination at the final holding tank. 5. Usage of treated sewage. Mandatorily the treated sewage shall be used for the toilet flushing with dual plumbing system. For gardening, lawn maintenance and landscape including vertical garden. The usage is considered at 5 lieutenant per every square meter of landscaped area. The treated water shall be used for the construction activity, other than the places where the treated water does not come in contact with the steel either directly or indirectly. 6. Adoption of modular-based approach. It is found that in many large projects, especially the layouts, the occupancy is minimal in the initial stages. The adequate quantities of sewage is not generated at the time of occupancy for the effective operation of STPs. Hence, the design and execution shall be on a modular basis so that STP can be made operational during the lean occupancy also. 7. Location of STP. STP shall preferably be located under the driveway, clubhouses, play area, and as far as away from apartment complexes. Never locate the STP in the basement of any flats or apartment towers. The access from the lowest basement is not permitted for the reason of flooding of rainwater, smell, and sound nuisance. The water pathway. Existing water systems are often inefficient. Water is lost, polluted, wasted and misused. Such systems will continue to exacerbate the projected gap between available freshwater supply and demand. The water pathway should be developed as a closed-loop system. Practicing circular economy in water management can reduce The burden on natural water resources. Circular economy in water management. The minimum liquid discharge principle ensures less wastage of water. Recovered water quality meets reusable water standards. Wastewater is another water source. Water can be reclaimed with the use of advanced technology. With more than 95% of water recovery, the requirement of fresh water can be minimized. Less dependency on natural water sources. Green Float STP. Working principle and key reactions. Oxidation or reduction. Hydrocavitation. Sweep coagulation. Charge neutralization. Flotation, air-assisted buoyancy. Electrophoresis. Disinfection. Cod reduction with Green Float STP. Removes cod by 70 to 80% in a single step. BOD is also reduced proportionally. Treated water meets discharge standards of CPCB. Coagulates suspended solids and floats on the surface, which are further scrapped and collected in sludge tank. Oxidizes organics and reduce soluble, suspended cod. Destroys pathogens. Catalytic electro-oxidation. Catalytic electrocoagulation involves dissolution of metal from the anode with simultaneous formation of hydroxyl ions and hydrogen gas occurring at the cathode in the presence of catalyst. CEO units are used simply as a replacement for chemical dosing systems. How CEO is helping to reduce pollutants. Migration to an oppositely charged electrode, electrophoresis, and aggregation due to charge neutralization. The cation or hydroxyl ion, O, forms a precipitate with the pollutant. The metallic cation interacts with O to form a hydroxide, which has high adsorption properties, thus bonding to the pollutant. Bridge coagulation. The hydroxides form larger lattice-like structures and sweep through the water. Sweep coagulation. Oxidation of pollutants to lesser toxic species. Removal by electroflotation and adhesion to bubbles. Photocatalytic oxidation reactor. Sewage is further oxidized by dosing strine oxidant in catalytic oxidation reactor. With presence of a catalyst and medium pressure low intensity high pressure radiation. The high or low molecular weight compounds are oxidized and are converted into CO2 and water. To remove gaseous compound, we either deaerate or filter it to a special graded activated carbon to remove traces of low molecular weight substance, color, odor, etc. The attack by the O radical, in the presence of oxygen, initiates a complex cascade of oxidative reactions leading to mineralization of the organic compound. This advanced technology, which is being used for treating complex industrial wastewater, is very efficient and removes up to 95% of cod and BOD. Air assistant buoyancy. AAB is a purely physical process which operates based on a reasonably simple design philosophy. AAB systems are designed for pressurization and air emulsification of the total flow, or, more commonly, the incoming effluent enters the AAB vessel where it comes into contact with a portion of recycled, treated effluent. Air bubbles rise due to buoyancy they attach to the solids or chemical flocks in the vessel, causing them to float to the surface where they are retained by buoyancy and subsequently removed. A key application of AAB includes the removal of free and emulsified hydrocarbons from petrochemical and similar wastewaters upstream of biological processes. AAB systems are superior processes when compared with more traditional gravity-based settlement systems. Reduction in space requirements can be achieved. A thicker sludge can be produced. Highlights. Complete physical process, doesn't depend on biological activity. Need no clarifiers. Compact design and small footprint. Safe and high-quality effluent. Automatic, flexible, continuous and on-demand process. No odor problem because of physical process. Low power consumption. Easy to install, operate and maintain. Low sludge generation, 70% less than conventional, and easy handling. Comparison with biological treatment. Biological process depends on bacterial activity. Not suitable for today's complex nature of sewage containing residual drugs, hormones etc. And in green float STP. Physical process, catalytic electro-oxidation process followed by photocatalytic oxidation. Manual operation which needs continuous human attention. And in green float STP. Full automatic simple operation with minimum human dependency. Shock load of impurities and spike in cod or bod cannot be handled. And in green float STP. Can handle shock loads. The process can continue with minimum water flow. Sludge quantity is more due to bacterial growth. And in green float STP. Sludge quantity is 70% less compared to conventional biological process. Sludge density is very high. Depends on noisy large blowers. Not suitable for places close to school, hospitals or close residential places. And in green float STP. Silent operation suitable to put up the plant near to residential places also. Mainly open tank process leads to odor problems to nearby places. And in green float STP. Closed process ensures no odor problem. Retrofitting is difficult as depends on large aeration tanks. Need fresh new land. And in green float STP. Existing tanks can be used as process tanks. Suitable for retrofitting. Components can be added to the existing STP unable to process as per the new required specifications. Usually requires large aeration tanks, sedimentation tanks. And green float STP. Requires small space compared to conventional treatment systems. 100 KLD plant requires less than 500 SQ feet. Our planet has no alternate, let's save it. Promote, practice, implement circular economy. Thank you for your time. Presentation by Adstock Global Technologies Private Limited. Bangalore, India.